We have covered various points in the chapter the crystalline state. For example, we have seen what is atomic radius, how to calculate atomic radius, what are the values of atomic radius for SC, BCC, FCC. For example, for SC, atomic radius value is R is equal to A by 2. For BCC, atomic radius value is R is equal to root 3 by 4 into A. For FCC, atomic radius value is root 2 by 4 into A. Like that, we have also seen the packing factor values for SC, BCC and FCC. They are found as 0.52 for SC, then 0.68 for BCC and 0.74 for FCC crystals. Then we have seen what is the relation between A and D, and the formula for this is given by D is equal to A upon square root of h square plus k square plus l square, where D is interplanar distance and A is cube age and h, k, l are the Miller indices on respective axes. Then we have covered the formula related to density also, and it is given by rho is equal to Zm upon n into A cube, where rho is the density of crystal or density of unit cell. Z is nothing but number of atoms per unit cell. In some textbook it is given by small n also, but as in this chapter we are considering small n as order, so we have selected Z. It means that we can represent number of atoms per unit cell by Z or n also. Then molecular weight of a substance. Here we have mentioned with capital M. In textbooks it is mentioned with capital A. This is the small change that we have made. Then what is N? N is nothing but Avogadro's constant. It's a constant quantity and its value is 6.02 into 10 to the power 26 in MK system. Many times it is given in the exam, but if it is not given, then you have to remember this. So rho is equal to Zm upon n into A cube, and A is nothing but the cube age or lattice parameter, and A cube is nothing but volume of the unit cell. So by using all these formulae, let's try to solve few of the examples based on this chapter. Let's start first. Let's see first example. Here I am going to read the first example. Ion has cubic lattice parameter 2.9 angstrom. Density of ion is given as 7.87 gram per cc and atomic weight is given as 55.85, and you have to calculate what is the cubic structure of ion. It means that lattice parameter, that is A value, is given as 2.9 angstrom. Then density is given, that is rho is given 7.87 gram per cc. Atomic weight is given, that is, suppose in textbook they have considered it as A, capital A is equal to 55.85, and you have to find out the structure of ion. It means that it is having simple cubic, body center cubic or face center cubic. Then how to determine it? We have already seen number of atoms per unit cell. Suppose Z value is 1, then it belongs to SC, simple cube. It will show simple cubic structure. If Z value is 2, it will show body-centered cubic structure, and Z value is 4, then it will have face-centered cubic structure. It means that indirectly we have to find out value of Z, that is small n. So what is the formula? Let's find the given. In given, rho is equal to 7.87 gram per cc. It is given in CGS unit. How to convert it in MKS? By multiplying it with 10 raised to 3. You will get kg per meter cube. Then A value is given as 2.9 angstrom. As we have taken rho in kg per meter cube, you have to take A in meter. It will be 2.9 into 10 raised to minus 10 meter, because we know that 1 angstrom is equal to 10 raised to minus 10 meter or 10 raised to minus 8 centimeter. Then A value is given as 55.85 and N is given as 6.023 into 10 raised to 26 atoms per kg. So we know that the formula for density is given by rho is equal to Zm upon N into A cube. I have already mentioned that in textbook they have used the notation of small n for Z and notation of capital A for molecular weight, that is m. So by using this formula you have to find out Z value. So Z value, formula for Z value becomes Z is equal to rho into A cube into capital N upon A. Rho into A cube. A cube means, what is A cube? Volume. And N, Avogadro's constant, divided by A, molecular weight. Substitute the values in the formula. Is equal to N is equal to, that is Z is equal to 7.87 into 10 raised to 3 into value of A is given as 2.9 into 10 raised to minus 10 raised to 3 into Avogadro's value is 6.023 into 10 raised to 26 divided by A is given as 55.85. If you substitute all these values and calculate with it gives as 2.069. But final answer should be a complete number because it denotes the number. So you have to consider atom will not have fraction. So you have to write the number as 2. So number of atoms per unit cell comes out as 2. Hence ion belongs to BCC structure. Do you understand this? Let's move to next example. Next example is related with relation between D and A, that is, it is one of the property of Miller index. Formula is D is equal to A upon square root of H square plus K square plus L square. Let's see. I will read the example. The lattice constant of aluminium unit cell is 4.04 angstrom. Find the interplanar spacing for the planes 1, 1, 0. Here, lattice constant is given. It means that A value is given and it is given in angstrom unit. You have to convert it into meter by multiplying it with 10 raised to minus 10 meter. Then what else is given? They have given us HKL values, that is 1, 1, 0. It means that H value is 1, K value is 1 and L value is 0. Then you have to calculate interplanar spacing. For interplanar spacing in this chapter there is only one formula, that is D is equal to A upon square root of H square plus K square plus L square. Then by substituting the values of A and HKL in the respective formula, you will get the value of D. Let's substitute the values. A value is given as 4.04 into 10 raised to minus 10 divided by square root of h value is 1, so 1 square, plus k value is 1, so 1 square, plus 0 square. It comes out as 2.02 into 10 raised to minus 10 meter. You can keep the final answer like this, or you can convert it into angstrom. In angstrom it becomes 2.02 angstrom. So interplanar distance or spacing is 2.02 angstrom. The next example. Next example is also related to the same formula, but for different planes and different lattice constants. So just now I have explained you the procedure, so you can easily find out the D values. A is given as, I will read the example. Find the interplanar spacing for the planes 201 in cubic crystal of the lattice constant 4.3 angstrom. A is given as 4.3 angstrom, that is 4.3 into 10 raised to minus 10 meter. HKL value is given as 201. It means that H value is 2, K value is 0 and L value is 1. By substituting these values in the formula, D is equal to A upon square root of H square plus K square plus L square, one can easily find out the lattice constant value. Interplanar spacing, that is D value. So D is equal to 4.3 into 10 raised to minus 10 divided by square root of H value is 2, so 2 square, plus K value is 0, so 0 square, plus L value is 1, so 1 square. So 4.3 into 10 raised to minus 10 divided by square root of 4 plus 1, that is square root of 5. It gives the value as 1.923 into 10 raised to minus 10 meter. Again, one can express it in angstrom as 1.923 angstrom. Now next example. This example is based on Miller index. We have seen what is Miller index, how to find Miller index of a plane, and how to draw few of the Miller planes. This example is related to finding the Miller index of a given plane. So let's read the example. In a crystal, a lattice plane cuts intercept of a twice b A, twice b, thrice c along 3 axes. It means that given plane cuts the axis at A, twice b and thrice c, where A, B, C are primitive vectors of unit cell. Determine the Miller indices of the given plane, and you have to determine the Miller index of a given plane. Then how to calculate it? There is one procedure. What is that? If you want to find the Miller index of a given plane, the first step is you have to write down the intercepts made by plane with 3 axes. That is, they are given as A, twice b and thrice b. The next step is you have to convert this intercept in numerical parameters. It means that you have to divide A by A, then twice b by b and thrice c by c, that is by lattice parameters. Then it will give us numerical parameters as 1, 2 and 3. Now you have to take the reciprocal of these numbers, that is reciprocal of 1 is 1 upon 1, 2 is 1 upon 2 and 3 is 1 upon 3. Now look at the denominator. Denominator values are 1, 2 and 3. Now you have to find out the LCM of denominator in order to clear the fractions. So it comes out as 6. Now take this LCM and multiply the reciprocal with LCM, and it will give us 6 into 1. 1 upon 1, 6 into 1 upon 2 and 6 into 1 upon 3. If we make the division, then you will get 6, then 2 ones are 2, 2 threes are 6, 3 ones are 3, 3 twos are 6, 2. That is 6, 3, 2 will be the Miller index of a given plane. Don't mention any comma while mentioning the final answer in a bracket. Otherwise, it will be wrong.